How we doing, guys? You're looking at measures of spread today. Now these are the four measures we'll talk about: range, interquartile range, standard deviation, and percentiles. But what do we mean when we talk about spread? We've talked about center, which is kind of what's maybe a good number that represents the data overall. But within that as well, there's a big difference between a data set that looks like, for example, 3, 5, 7 has a center of 5. It's an average of 5. It's a median of 5. But so does 5, 5, 5. Okay, that's called a uniform set because its spread is 0. It really isn't spread out at all, where there's more spread on this data set here. So how do we measure that? One way is the range, which you met for junior cert, which is the highest minus the lowest. So for question 2, it's the first thing that they ask us to do. This is on page 392. It's going to be 37, take away 4. So the range there is 33. I think this is points in a test, so 33 points is the range of tests. You'll sometimes also see range written as from 4 to 37, which is fine as well. The next part of that question asks you for the the median mark. Okay, so that's the middle mark in an ordered set. Then we're going to be asked for the lower and upper quartiles and the interquartile range, which I'll tell you what they are shortly. The median mark there is the middle number in an ordered set. So there it is, 29, median. There are 4 marks below 29 and 4 marks above 29. So that gives us a good idea of the center. And the lower quartile is if you take the bottom half of your data, so these 4, it's the median of that half. So the lower quartile, LQ I'm going to call it, 10 plus 27 over 2. 37 over 2 is 18 and a half. Okay, that's sometimes called quartile 1 as well. Your median then, so that's 18.5 would be here. Your median is sometimes called quartile 2, and then quartile 3 is the middle number of the top half of your data. And you can see there, 34 plus 34 divided by 2 is going to be 34. So the upper quartile is 34. And then the interquartile range, upper quartile is 34. The interquartile range is going to be 34, the upper quartile minus the lower quartile of 18.5. What's that give us? 14, 15.5. Okay, and the advantage of this as a measure of spread by comparison with the range is that the range takes the most extreme values and tells you what's the gap. Okay, but maybe if you had outliers, that's not that useful a measure. Whereas this one, it doesn't take the most extreme values. It takes a number near the top and a number near the bottom and tells you what the gap is. And it maybe gives you a better picture of the data. Certainly, if you have both these interquartile range and range, it gives you an idea of, is there a lot of outliers, or how is my data spread out? Now, question 7 asks you for something called the standard deviation for each of these following arrays of numbers, giving your answer correct to one decimal place. I'm going to show you how to do the calculation for part 1, and then discuss maybe the merits of the standard deviation. Right, so here is our set of numbers, 1, 3, 7, 9, 10. The mean value, add them all together, divide by, there's 5 numbers, so divide by 5 for these numbers is 6. Okay, and these are 2 notations for mean. They're slightly different. When we get to inferential statistics, we'll talk about the difference between those 2 notations. But really, if you see either mu or x bar at the moment, you can think mean. The log tables give you a formula for standard deviation here, where they say mu is what they're using for mean. N represents number of elements. So for us, that's 5. And x is each individual element. This is the sum of each individual element. Okay, minus the mean squared divided by n, and then take the square root. So let's follow that formula and see what we get. Okay, so sigma is the square root of the sum of the elements minus the mean squared all over n. Well, for us, our first element is 1, minus the mean is 6, and then squared, plus, that's the sum of, means add them all together. 3 is the next element, minus 6 squared, always minus the mean, plus 7 minus 6 squared, plus 9 minus 6 squared, plus 10 minus 6 squared. All divided by the number of elements for us is 5, and then you take the square root. Okay, now what are we doing here? Well, we're getting -5 squared. That's how far this number is from the average value 6. Okay, plus -3 squared. That's how far this number is from 6. Plus, that's going to be 1 squared. 1 is how far this number is from 6. This is 3 from 6. So 9 take away 6 is 3 squared plus 4 squared. So what we're finding here is a type of average distance from the mean. Okay, sorry, I'll divide it by 5. Okay, and because we squared everything, everything is going to have a positive value now. That's going to be 25 and 9 and 1 and 9 and 16. You're going to have all positive numbers, so they're not going to cancel each other out with the numbers above average and below average kind of canceling each other. You're finding the total distance and you're squaring it so that you get a positive value for how far you are from the average. Then you take the square root to kind of undo that, if you like. Okay, you're dividing by 5 because you're finding an average. So what do we get there? We're going to get the square root of 25 plus 9 plus 1 plus 9 plus 16 over 5, and that's going to be 35, and another 25 is 40, 50. Square root of 50 over 5. That's the square root of 10. Okay, so the standard deviation here for this data set is 3.1. 3.2, I suppose, if we're working to 2 decimal places. Okay, or the square root of 10. Now, if you come back and look at the data, you're trying to say, well, on average, how far are we from 6? And about 3 seems right. Okay, that's 3. That's more than 3. That's 3 from 6. That's more than 3, but that's a bit closer. So it's an average distance from the mean is what you're finding here. That calculation is a mess. It's an unholy mess. The only time you'll be given really that calculation is with very small data sets, or well, yeah, it'll always be small data sets if they want you to do it by hand. For any big data set, your calculator can do this for you. I'm going to produce a second video, I think, on how to produce the standard deviation using your calculator. Okay, so if you can, you probably watch that tonight as well. Now, there's a mistake there. That should have been 60, so it's the square root of 12, and I think that comes out as about 3.4. And I am going to show you now rather than a separate video. So what you're probably going to have initially is a calculator that's in normal mode. This is using the Sharpie Alto. This is the calculator that's on our book list. If you're working with a Casio calculator, can I point you to page, excuse me, 390 there, where they talk you through in the textbook how to do this on a Casio calculator. And all Casios are pretty similar and all Sharps are pretty similar. So to come back to the Sharp for this data set for question 7 here, we're going to say, right, first of all, what mode do I want to go into? So choose mode, option 1, statistics, and then it's option 0, the standard deviation of a set of numbers is what you're interested in. So how do you enter these 5 data points into your calculator? Well, you say 1, and then this button here that has data above it, or change. If you hit that, see it says data set equals 6. Now that says 6 because I've already got data stored in my memory. So to clear my memory, it's second function and that clear all button, okay, just above mode. So I'll do that again. 1 gets entered and it says data set equals 1. That means I've stored 1 element in my calculator's memory. Do that again. 3, I've stored 2 elements now in my calculator's memory. 7, data, that's 3 elements stored. 9, that's 4 elements, and 10. So that's 5 elements I have stored in my in my computer, in my calculator's memory. I can hit off or whatever. That's all stored now. So what I want now is the standard deviation, which is this green sigma x down here, and I access that by saying alpha, and then sigma x comes up there. Okay, so the standard deviation of this set of numbers, 3.46. Okay, so you don't necessarily need to do the calculation by hand, but you should do 1 or 2 calculations by hand, get a bit familiar with it, and you might be given an algebra question or something at some stage where you need it. But for the most part, you'll be working off your calculator to do this. Okay, question 8 then is excuse me, sorry, now I'm not sharing. Question 8 is an interesting one. This set of numbers 2, 3, 4, 5, 6 and 12, 13, 14, 15, 16 are the same set of numbers, just increased by 10. Okay, so you increase all these numbers by 10. So they have the same spread. That's what we're looking at here, even though their center is different. This has a center of about 4 and this has a center of about 14 in our second set. But we're going to be asked, what is the relationship between their standard deviations? And I think when we do this in the calculator, we'll find that it's the same. And the conclusion will be that the spread of these two sets of numbers is identical. Okay, so clearing our memory, second function, clear all. That's going to clear our memory off. And then we're going to say enter 2, 3, 4, 5, and alpha, and this 6 to get that sigma x. Gives us, I didn't enter all of them in, did I? 6, excuse me. Okay, so data set equals 5. I've got 5 elements entered, 1, 2, 3, 4, 5. Alpha sigma x is 1.41 for this first one. Okay, sigma is 1.41. And for the second one, sigma is going to be, well, clear our memory and go 12, enter, 13, enter, 14, 15, 16, enter, alpha, and then sigma x equals 1.41 as well. Okay, so they have the same spread, the same standard deviation, which means these two data sets have the same spread, even though they have a different center or a different average. Okay, so as well as making sure you've got question 2 and 7 part 1 done in your copy, can I ask you now to do question 3, please? And 7, if you can finish that off, they want you to do question 7 twice, once by hand and once with your calculator, okay? And you do need to learn how to do that formula by hand, and it'll kind of give you a sense of it a little bit better as well, rather than just bashing into the calculator every time. So if you can give that a go, and I'll see you next time. Bye-bye.